Good day, students. Welcome to Mathgotserved.com. In this clip, we're going to be going over problems 30 to 34 of the June 2016 Geometry Common Core New York Regents exam. All right, let's take a look at question 30. It reads, a ladder leans against a building. The top of the ladder touches the building 10 feet above the ground. The foot of the ladder is 4 feet from the building. Question, find to the nearest degree the angle that the ladder makes with the level ground. Okay? So let's start off by giving ourselves a visual representation of this scenario. So let's start with the level ground, okay? So this right here is the level ground, and we have a wall. Of course, we expect the wall to be perpendicular to the level ground. So there goes your wall right here. And then what we have is a ladder leaning against the wall. Okay, so let's sketch our ladder. Ladder right there leaning against the wall. Now, let's put in the measurements that we have. So we're told that the top of the ladder touches the building 10 feet above the ground. So the distance from the top of the ladder to the ground level is 10 feet. Okay, so let's put in that measure. So this is 10 feet. And then the foot of the ladder is 4 feet from the building. Okay, so this is the top of the ladder, and this right here is the foot of the ladder. Okay, so we're told that it's 4 feet away from the building. So right there, it's not drawn to scale. Okay, so just bear with me there. So this is 4 feet. So the question is, what is the angle that the ladder makes with the level ground? So this angle right here, what is it? Let's call it theta. All right, this is a ladder. All right, so that's what we're going to be looking for. So what I'm going to do, let me just sketch a right triangle. All right, so let's sketch the right triangle. Like this. Okay, so let's put in the measures. This is 10. This is 4, and this is what we're looking for here, theta. Okay, all right, so we are dealing with a problem that involves the ratio of two sides of a triangle in relation to an angle. So what formula relates the ratio of two sides and an angle of a right triangle? Let's write down that formula first. So formula that we're going to be using here is SOHCAHTOA. Okay. All right. So which of the trig ratios are we going to be using? Sine, cosine, or tangent? Well, let's take a look at this triangle. This is the angle theta. So the side opposite the angle under consideration, that's going to be our opposite. That's O for SOHCAHTOA. And then this side right here is the adjacent. The longest side, namely the side opposite the 90 degrees, is the hypotenuse. In this problem, we don't know it. We don't need it, so we scrap it, okay? So we're looking at O and A. Now, which trig ratio, sine, cosine, or tangent has O and A? It's tan, right? So we're going to be using the tan component of SOHCAHTOA. So the formula, to be more specific, is tan theta equals opposite over adjacent, all right? Okay, now let's apply to this situation that we have here. Tan theta, which is what we're looking for, is going to be our opposite over adjacent. So if we substitute values from this triangle, theta is unknown, it remains a variable. The opposite is 10 and the adjacent is 4. Now to get theta isolated, we have to undo the tan function. And how can we undo tan? Do we divide? No. What we do is we use the inverse tan. Okay, so you take, not multiply, you take the inverse tan of both sides of the equation, and that will eliminate the tan function that you have on the left side. So that cancels out. So theta is the inverse tan of 10 over 4. All right, so we're going to let our calculator finish this off. So we're going to compute the inverse tan of 10 divided by 4. And the answer is 68.1985. But we are to, well, let's just write it down. So 68.1986. All right, so theta is going to be equal to 68 degrees to the nearest degree. Okay, that's what the problem asks us to do. So when we're rounding it to the nearest degree, we're rounding it to the ones place. The number behind it is less than 5, so we just truncate the entire set of numbers to the right of the ones place, and then our final answer is 68 degrees. Okay. All right, let's take a look at question number 31. It says in the diagram below, radius OA is drawn in circle O. Using a compass on a straight edge, construct a line tangent to circle O at point A. Side note, leave all construction marks. Now, one thing you want to keep in mind is that there's a theorem concerning tangent lines and their radius of circles to the point of tangency of the tangent line. And what you want to note is that if you have a line that's perpendicular to the radius of a circle at its endpoint, then that line is tangent to the circle. Okay? So what on earth am I talking about? Let me show you what I'm talking about. So we have a radius here. If I draw a line perpendicular to this radius at this point of tangency right here, guess what? Our point of intersection, I meant to say. So if I draw this line and it's perpendicular to the radius at its endpoint, then that automatically means that this line, let's call it L, is going to be tangent to the circle. Okay, so that's the main idea. All right, so let's go ahead and carry out the construction. These are the steps we're going to use. First of all, we're going to extend the radius OA out to a point, let's say C. Then we're going to construct a line perpendicular to OC through A. Okay. That line that we construct that's perpendicular to this radius, or the line OC, will be tangent to circle O because it's perpendicular to the radius. All right. So let's go ahead and do it. I'm going to be using a computer to do the whole process, so it's going to be a little bit weird. So just bear with me. Okay. So first thing to do, let's go ahead and extend the radius. Just make sure that the line fits in perfectly with the existing radius that you have. So you have that line right. Make sure it's perfect right there. Okay. All right. Now, let me see if I can make it a little bit skinnier. Okay. Now, what we're going to do, let me call this point here point. Let me make it longer before I name it. A bit longer. Let's call this point C, okay? So we've done step 1, which is to extend the radius out to point C. Okay, so what we're going to do is we're going to construct a line that's perpendicular to OC, okay? I'm going to be using my nice little tool here. So let's see. What we're going to do is just make an arc here. Think about creating a perpendicular bisector. So we're going to create a perpendicular bisector of a certain region going through this line. Okay, so that's the main idea. So in order to do this, I will start from the center. Let's make this a little bit smaller. So put the tip of your compass on point A. Okay. Okay, and then we're gonna make 2 arcs of equal radii. So let me rotate this a little bit. All right, so I'm gonna mark right here, and keep the tip on A, okay? And then rotate your compass to the other end and mark it. All right, so what I'm going to do is I want to create a perpendicular bisector of this segment right here I just created. All right, so to do that, I'll just put one tip of my compass on one end and then extend the compass out. Doesn't matter how far you put it. So we'll rotate it and then we'll make an arc right there. And then bring it down to the other side. Rotate a little bit more. And then make another arc right here. Okay. Now what do we do next? You move the tip of the compass to the other end. All right. It's just the algorithm for creating perpendicular bisectors. That's what we're doing. Okay. Looks like I didn't make it long enough. Okay. So let's make an arc right here. And rotate it to the other end. This one's nice, better. And it will make another arc right here. Okay. My compass has gone away. Let's see if I can bring it back. Okay, so what I'm going to do, I'm going to put it right back here. This arc that I made, this is not long enough, so I got to go back here and extend it. So this arc right here, just make it a little bit longer so it intersects, okay? Bam, like that. So do you see the perpendicular bisect of this little segment we created here? It's a line through these 2 points of intersection, okay? So let's go ahead and draw that line. We're going to call it line L. So just go from this point through there, bam, like that. So what we just created is a line perpendicular to the radius, okay? It's called line L. So let's just write a real quick statement. Since line L is perpendicular to the radius OA, it is tangent to circle O at the point of tangent CA. Okay, so this is the line that we're asked to construct, the line that's tangent to circle O. All right, let's take a look at question 32. It says a barrel of fuel oil is a right circular cylinder where the inside measurements of the barrel are diameter 22.5 inches and a height of 33.5 inches. There are 231 cubic inches in a liquid gallon. Question. Determine and state the nearest tenth the gallons of fuel that are in a barrel of fuel oil. Okay, so let's go over the steps that we're going to be using to solve this problem. Step number 1 is we're going to figure out find the volume of a barrel. Okay, find the volume volume of the barrel. Of the barrel, and it's going to be in cubic inches. Okay, so find the volume of the barrel in cubic inches, and then part 2 we're going to convert to gallons. Convert the volume to gallons. All right, so that's all we're doing. Okay, so there goes a sketch of a circular cylinder. So we have a barrel with the given dimensions. So let's go ahead and populate the measures here with the dimensions that we have. So we're told that the radius, actually the diameter is 22.5. So this entire thing right here is 22.5. Okay, so that's 22.5. And the height of our barrel is 22.5 inches, and then the height is what? What is the height? 33.5 inches. So the question is, part one, let's find the volume, okay? So I want to find the volume of this barrel that we have right here. So step one, find the volume, find the volume. Okay, so before we start, we need to write down what the formula is for determining the volume of a circular cylinder. Okay, so volume, you can consult your reference sheet for this, is pi r squared, the area of the base multiplied by height. Okay, all right, so let's find it. In this problem, the radius, you gotta be careful here, is the diameter divided by 2, okay? You are provided with the diameter, not the radius. So what you have to do is you take 22.5 and divide that by 2. 2 goes into 2, 1, 2 goes into 2, 1, 2 goes into 5, 2, so it's 0.25, right? Okay, so there goes the diameter. The height, h is, what's the height? 33.5 inches. So your volume is going to be pi r square h according to that formula. So we'll just substitute in. We are going to have pi times the radius 11.25 square, and I multiply that by the height 33.5. Okay, when you multiply all that together, you let's put that in our calculator, see what we get. So we have pi times 11.25 square times 33.5. Enter. So 13319.86198. So our volume is 13319.86198. And guess what? The unit is in cubic inches, okay? So we did inches times inches times inches. We raised inches to the third power, so that's why I have cubic inches or inches to the third power. They mean the same thing. Okay, so we're done with step one, which is to find the volume of the barrel in cubic inches. Check. Next, we're going to convert that volume into gallons. Okay, this is just a unit conversion part. So part two, convert volume to gallons. Okay. Now there are two ways you can do this part. Okay. I'm going to show you both methods, and whichever one you like to use on the day of your test, go ahead and use that. You should be fine. So let me show you the first method. The first method involves the use of a conversion factor. Okay. Method one, I'm going to call this conversion factor. Okay, so in this problem, we have a conversion factor. What is a conversion factor? You're told you have 231 cubic inches in a gallon. That's the conversion factor there, okay? So a conversion factor R, so conversion factors are 231 cubic inches per 1 gallon, or the reciprocal also holds true, 1 gallon per 231 cubic inches. Okay? All right, so you multiply by any of these depending on what you want. Okay, this one changes gallons to cubic inches, and this changes cubic inches to gallons. So we're going to look at what we have, and that will determine which one we are going to be working with. Okay? So we have in this problem, we have 13319.86198 cubic inches. So we have cubic inches. This needs to be converted into gallons. So which of these two are we going to multiply by? to accomplish that conversion. So we're gonna pick the one that has cubic inches in the denominator and gallons in the numerator. Why? Well, we want the cubic inches to cancel out and we want to be left with gallons. It's just like, think about changing degree to radians and radians to degrees, right? The same process. You want one unit canceled, so you're left with the other one that you desire, okay? So which one has cubic inches in the denominator? This one right here, that's the conversion factor we're gonna use, okay? So let's insert it. We have 1 gallon per 231 cubic inches. So check this out. The cubic inches and the cubic inches cancel out, and this product that we have here is your gallon factor. So what we're just going to do is we're going to have 13319.8619. 8 divide that whole thing by 231, okay? And the unit is in gallons. Okay, that's the only unit we have left, right? Okay, so let's go ahead and do that with a calculator. So we have, the answer is already there, just divided by 231. Enter, 57.6617. So let's write it down, 57.6617 gallons. But in this problem, we're to round it to the nearest tenth, okay? So our answer is going to be volume in gallons is 57 point. Now we're rounding to the 10th place, right? So we're gonna truncate right here. Look at the digit behind it. It's 5 or greater, so we're gonna round up. Add 1 to 6.7 gallons. Okay, so that's your answer. Okay, so this is one way of doing it. There's another way of doing it. Method 2. This method is known as using ratios, okay? Some people prefer using ratios. I like using ratios, but if you like conversion factor, this is more scientific. All right, method 2 is the system of using ratios. Okay, all you do is just set up 2 ratios and solve for what you're looking for, okay? So in our setup of our ratios, it doesn't really matter what you put, but if you put what you're looking for on the top, it saves you time. I'm not gonna do that. I'm just gonna make it a little bit longer, okay? So I'm gonna have cubic inches was gonna be in the numerator, and then gallons will be in the denominator. All right, I'm gonna set up a proportion in a second. All right, so what do we know? From our conversion factor, we know that for 231 cubic inches, we have 1 gallon. Bam, okay? So we also know that for 1319.8619 cubic inches, how many gallons do we know? Do we have? We don't know. That's what we're looking for. Forget about this, okay? Remember, we're looking for the value of this in gallons. So you just set it up like this. The conversion factor, 231 per 1 gallon, equals 1,319 per x gallon. So x is what we're looking for, okay? All right, so all we just have to do now is just solve this equation for x, and that's it. You can forget about the units and just solve for x. That'll be fine, but I'm going to keep the units, okay? So how do you solve this ratio? Cross multiply, right? Bottom right to top left, bottom left to top right. If you multiply across, you have x gallons times 231 cubic inches equals 1 gallon times, I'm running out of space, 13319.8619 cubic inches, okay? All right, we're trying to get x by itself, right? X gallons, so what are we going to do? We're just going to divide both sides by 231 cubic inches, right? Now we're solving an algebraic equation, so divide both sides by 231 cubic inches. and here 231 cubic inches. And then this divides out. You have x gallons equals, now the cubic inches and the cubic inches cancel out, and you're left with 13319.8619. 8 divided by 231, and the unit is the unit of the 1 here. That's all that's left. Bam, that's exactly what we have here. And if you do the computation, you end up with 57.7 gallons to the nearest tenth. Okay, so this is just another way of doing exactly the same thing. All right, let's take a look at question 33. It says, given parallelogram ABCD with line EFG and diagonal DFB, prove that triangle DEF is similar to triangle BGF. Okay, so you just want to recall your similarity postulates and theorems. Okay, so recall SSS, 3 sides, corresponding sides in proportion. SAS, 2 corresponding sides in proportion with the included angles being congruent. Or AA, a pair of congruent angles are sufficient to prove similarity. Okay? Okay, so in this case, we're looking at this triangle and this triangle right here. We know that this side is perpendicular, it's parallel to that side. When you have two parallel sides cut by a transversal, some congruent measurements should come to mind. See this angle right here? This angle and that angle are congruent because they're alternate interior angles. All right, so we have an A, okay? And guess what? This angle right here is congruent to this angle right here. How do we know that? They're vertical angles. We have another A, ladies and gentlemen. So we can use these two angles to conclude that these two triangles are similar based on the AA similarity postulate. All right. So remember what we're looking at is this triangle right here and this triangle right here. That's what we're trying to prove are similar. Okay, so let's leave the markings there. They're going to help us as we write our two-column proof. So let's get started. Statement and reason. Statement and reason. Okay, so let's start with what we're given. Okay, so ABCD is a parallelogram. ABCD is a parallelogram. How do we know that? Well, it's given. Okay. All right, and let's talk about angle. Let's talk about angle ADB and angle C. Well, let's focus on the triangles. Okay, so angle EDF and GBF. All right, so statement 2 is that let's see. Well, before we can talk about these are alternate interior angles of two parallel lines cut by transversal. So we have to state that these two lines are parallel. So DC, line DC is parallel. Segment DC is parallel to segment AB. Okay, how do we know that? We know that opposite sides of a parallelogram are what? Are parallel. Okay? Okay, so we have that down. Now we can go ahead and talk about those two alternate interior angles. All right, so angle EDF is congruent to angle, so we have EDF, GBF, okay, GBF. And how do we know that they are congruent? Alternate interior angles of parallel lines cut by transversal are congruent. Okay, pardon my shorthand there. I'm kind of running out of space. Okay, so that's the whole idea. If you have two parallel lines cut by transversal, then alternate interior angles are congruent. Okay, so that gives me the A portion of the AA similarity postulate, and then we're gonna go to the last one, 4, which is stating that this angle right here is congruent to this angle right here. So this one and this one. All right, so let's write it down. So triangle EFD, angle EFD is congruent to E corresponds to G, right? So G, GFB. So GFB is congruent to angle GFB. Well, how do we know that? They are vertical angles. Okay, vertical angles. And that's the second A we need. Okay, so we have two angles that are congruent. Guess what? We can automatically conclude that the two triangles are similar. So let's write down our concluding remark. Statement number 5. Triangle DEF is similar to triangle BGF. What's the reason? By the AA similarity postulate. Okay, so that's that. All right, let's take a look at question 34. It says in the diagram below, triangle A prime, B prime, C prime is the image of triangle ABC after a transformation. First question, describe a transformation that was performed. Now, if you look at A prime, B prime, C prime, it is bigger than A, B, C, okay? So if there is an alteration in size, there's automatically a dilation. We have a dilation going on here, okay? So the question is that the only thing? So let's see where the dilation is centered about. If it's centered about the origin, then we don't have to bother ourselves, okay? But if there's some kind of movement, a transformation, a translation, or a translation then a dilation, then we have to take that into consideration. Okay, so how do we know if this dilation is centered about the origin? Let us see. All you simply do is mark the origin. This is the origin, ladies and gentlemen. And I'm going to draw a line from the origin through the vertices of the image and the object. Okay, so see this right here? Bam, that's a perfect line. And then through A. Bam, that's a perfect line. See that? And then this one. Yeah. So it's just a dilation. That's what this tells me, that it's just simply dilation. It wasn't shifted first before it was dilated. It was just dilated, okay, about the origin. So if we want to describe the dilation here, we know for one thing that is dilated about the origin. Let's take that out. That's dilated about the origin. So dilated about the origin. Okay, but what's the factor of dilation here? By what factor was it scaled? So you look at BC, and the object and then you look at the image B prime C prime. Okay, so you look at BC. BC is equal to, count the number of boxes, 1, 2, 3, 4, 5, 6. And then B prime C prime, the image is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Is equal to 15. Okay, so what's the dilation factor? So let's write that down. Just going to put it here. So dilation factor is simply your image length divided by your corresponding original length. Okay, so you just pick a side length of the image triangle and then divide it by the corresponding side of the original triangle. Okay, so that's the formula that we're going to be using for the computation. All right, so let's find out the dilation factor. So dilation factor in this problem is going to be the image B prime C prime is 15 divided by the original, which is 6. So let's reduce that, divide top and bottom by the GCF, which is 3. So that yields 5 over 2. Okay, all right, so let's put it together. So let's write down our description. The dilation, I'm sorry, the transformation is a dilation of a factor of 5 over 2 about the origin. Okay, so that's the answer that this problem is asking for. So you state that it's a dilation about the origin, and then you also indicate what the dilation factor is, which is 5 over 2. Next question, explain why a triangle A prime B prime C prime is similar to triangle ABC. Well, when you dilate an object, the angular measures are preserved. Okay, so since the angular measures are preserved by the AA similarity postulate, you can conclude that the two triangles are similar. Okay, so let's write that down. Let's see. Since angular measures are preserved under dilation, triangle A prime, B prime, C prime is similar to triangle ABC by the AA similarity postulate. Okay, so that's basically that. Thank you so much for taking the time to watch this presentation. I really appreciate it. If you found the contents of this tutorial helpful in your preparation for your upcoming Geometry Regents exam, do give us a thumbs up. Your positive feedback is very supportive and encouraging to us. Okay, if you have any questions, just include it in the comment section below and we'll be more than glad to respond. Don't forget to subscribe to our channel for updates to the remainder of this review series. More clips can be found on Mathgotserved.com under test prep. Thanks again for watching and have a wonderful day. Goodbye.